Coming up right now, we have Nadia Fani. She's the founder of Shaper and Maker B.V. She's going to talk about 3D concrete printing, powder bed technology to save the oceans. So Nadia, let me pull you up on stage and we'll go ahead and get started. Oh, you're already on stage. Go ahead and you can turn your camera mic on. There you are.
Hello. Hello. Hello, everybody. I'm Nadia. I come from Italy, and as Christina already introduced me, I'm the founder of Shaper Maker. I'm first of all a 3D printer passionate, and I'm developing my way to be an expert in 3D printing concrete, with powder bed technology in particular. I felt in love with 3D printing already 5 years ago, when I discovered the infinite possibility that 3D printing could offer, like the freedom of the shape, but also the possibility to create any structure with different material in a way more sustainable and more circular, first of all. And but what really was more important for me was the possibility to bring back beauty in our daily life. So I joined D-Shape. D-Shape is a pioneer a company in 3D printing concrete with powder bed technology, and the founder was Enrico Dini. I joined them in 2015, and I lead the building of one of the biggest machine that is still on the market for 3D printing concrete. It was a 6 cubic meter machine for printing area, and now is being sold to Acciona and is sitting in Dubai, as you can see in the picture on the left. He has a long array of nozzles, around 350 nozzles. So leading this building, I could join a few great projects together with D-Shape. First of all was the printing with the prototype of Acciona of the first 3D printed bridge full in concrete without reinforcement, and they're sitting in Alcobendas in Spain. Another great project, it was the one that we did in collaboration with the European Space Agency, that instead of wanting to go to Mars, they are planning to go to the moon and building a base there. So they thought to use powder bed technology, 3D printing concrete, to print a lunar base on the moon. So what we did with D-Shape technology, we 3D printed a section of the wall, as you can see in the picture on the right. And we used regolite. It was a simulant of the lunar soil. Now the piece is sitting in the exposition center in the ESA here in the Netherlands. Another project that I was really fascinating as well, it was the artificial reef that we 3D printed with a more sustainable cement based on limestone cement. And we printed a few of these samples and we installed them in Bahrain on the coastline in the ocean, in front of the coastline of Bahrain. The goal was to provide habitat for the marine life and try to bring back some population of fish mainly, but all the marine life that it was a bit disappearing in that area. And as you can see in the picture on the right, it was a great success. And after a few months, less than 1 year, sorry, we had thrive marine life. So Boskalis approached us and he asked us to collaborate with the project of the artificial reef printed in the Mediterranean Sea for the Prince of Monaco. So I had the luck to follow all the process and of the project, from the thinking of the shape of the artificial reef, because the ginormous plus of 3D printing powder bed technology is that you can use the freedom of shape to think the shape to give to any animals their own habitat. So we've 3D printed this beautiful structure. As you can see here, there is the process of printing. There was quite a process because the structure, there were 2 meter diameter. We installed them in the sea in Monaco, thanks to Boskalis and the Prince of Monaco, the private reserve of the Prince. And the results was really great. Less than a year after, we had a great results, and we have a lot of algae. That was the purpose of the project, to repopulate the algae in the marine area that they were disappearing. So thanks to this great success, also WWF approached us, and in collaboration with the designers Alex Goat, we made this artificial oyster bank to repopulate oyster in the North Sea, in the north of the Netherlands. The design was made such that the installation could be really easy. As you can see, it was self-sustained, so we could place it in the sea without a fancy installation, and the results was really great. Also, this one, after around 10 months, less than a year, we had a great results in the North Sea. So after this project, I decided to stay in the Netherlands and found my company, Shaper & Maker. That's where I'm talking. I'm based in Rotterdam. And yes, I decided to continue the project of D-Shape and continue to improve the technology of powder bed 3D printing. So using the unique selling point of the freedom of the shape, the possibility of using different materials, also recycled materials, to lower to the minimum the footprint of CO2. And also the possibility of the scalability of the machine and the dimension. Oops, sorry. And analyze the business cases, the possible business cases, and with this technology, they are very broad. And you can start with the marine infrastructure that they bring a lot of plus, but also using powder bed technology, you can make art and replicas of antique and bring back beauty in an affordable price for everybody, and make your city and your town very unique with personalized piece of urban architecture, but also going in the housing market with this technology. We decided to stick with the marine infrastructure, and that's how we founded Co-Struction with the team of Co-Struction, to try to bring a possibility to save the corals. That is a matter that is very important because they are disappearing. With this technology, we will try to do our best to create sustainable structure for the marine environment. What we start doing with this, we created few products that we are planning to create. One of the first of all is the artificial reef next to the shore, based on the all the marine life and the thanks and the marine habitat. Yes, so all the marine life, especially on the coral reef, and another process is the marine habitat. So in the middle of the sea, when you have a wind farm, of course, the impact on the sea is really damaging. So you can install back some structure to help the marine life to thrive again, but also to protect our coastline, that they're very fragile, and the raising of the sea is an urgent problem to address. So a breakwater structure, there will be another possibility. So this is the vision as we envision our machine. Machine will be transportable, first of all, and will sit in place to print any structure that is needed, and we'll use local materials. So, for example, the beach, the sand from the beach, or the dredging material, but also the CO2 from the environment and the water, because that's are the material to create concrete, and that's are the material that the machine will work with. So it will be fully sustainable and transportable, so saving cost of transportation, and very easy to work with. And it will have a continuous printing in a way that the production is really important, the production time. What we did with team, it was here in Rotterdam. We built a small proof of concept of a machine with powder bed technology that I achieved a 2 millimeter of resolution, and I tried to use this different material as possible at this moment, and I create our first proof of concept. And after that, I create our first artificial reef prototype with 2 millimeter of resolution, with concrete based on limestone, and using the beach, the sand of the beach here in the Netherlands. On the right is not really clear the picture, but it is placed in the Sardinian Sea, in the harbor. Of course, there the goal was just to test the strength of the material and to see if it will sit in place, and it was a success. It's almost 1 year it's there and it's doing great. So after this, these are our ongoing projects. We have, thanks to Stimulings Fund, we got subsidy to create Coral Texture. Coral Texture is a project that is in collaboration with Reef. Ulrike and Marie are the founder, and they're based in Switzerland. And our goal is to use powder bed technology, 3D printing, with limestone materials as a base material for the concrete, and making a freedom of shape structure based somewhere, probably in Colombia will be based. So how are we going to do that? At the same time, we are developing to scale up our proof of concept to achieve our container-based idea with a full continuous production. On the center, you can see the middle, the hybrid solution that we are developing now, from a small proof of concept to a bigger, and then we will step ahead with the container-based. We are also trying to test as many possible shapes that we can imagine to prove the freedom of shape and also the freedom of the materials. Here in the right, I used Portland cement, but I used limestone and I used aragonite. Aragonite is a natural material based on carbonate. That is the proper material that the corals are made on. So will be perfect for the corals. Our team is based, that's me and Astrid Kramer, that I met her a long time ago, working for Boskalis. She's a very experienced marine ecologist, and she was one of the first to initiate the artificial reef project, and she's a value member of construction, together with Bastian Lammert, that he has few years of experience as a business developer and a business manager. Our mission is to combine technology with innovation and sustainability and circularity to improve, of course, the life under the water, to protect our fragile coastline, but also not only in the water, maybe in the next time, and to bring back beauty in our daily life. Of course, we have a great team. Next to our core team, we have Andres, that is an expert engineer that is helping to find out all the challenges that the machine is bringing. Alex Good and Vanistra Dreyer, that they are very expert designers, that they come up with in very great free of shape imagination structure. And our team in Italy, with Paolo, Pietro, and Emanuele, that they have a lot of knowledge thanks of the work that they did for this shape. Of course, we create in the last years, and our work is still going on to create a more expensive network, but we have biomimicry designer because we want to learn from nature, to replicate nature, and to save nature. So our biomimicry designers, Carlos and Lindy, and our expert, Francesca Di Maio, that works for the TU Delft here in the Netherlands as an expert in cement, that is also providing recycled cement, so for recycling old concrete. But also the valuable collaboration that we have with TNO, that is helping to, go ahead with the engineering challenge. But we are not only based in the Netherlands. Carlos is based in Portugal, and we have Marie and Ulrike in Switzerland, and Dave in Hawaii, and Andrew in Jamaica. So we are trying to expand, but for now we are based in Rotterdam, in RDM. RDM Innovation Dock is the Center of Innovation Additive Manufacturing in Rotterdam. We are collaborating also with Blue City, that is the Center of Innovation and Circularity and New Economy in Rotterdam. and the young marine life. The young marine life is one of the bigger reseller of marine life for aquarium and any tools and equipment for aquarium. So with them, we are testing our in small scales, our artificial reef to see their reaction with corals and all the marine life. Thank you so much for the attention. I hope I'm in time and still maybe sometimes for question. Yeah.
Hi there. Okay, so we do have a few questions over the Q&A. I think we could start with combining the first two. Why powder bed instead of extrusion, and what binder jet printer are you using?
Okay, well, the why powder bed technology, as I said, one of our goal is to use freedom of shape. So extrusion has a lot of limitation, and it doesn't have the nice roughness of outcome. Well, maybe I can. Thanks to powder bed, we could have this surface, so very smooth and not like the bumpiness of extrusion. But plus of all, we can make this kind of shape that with extrusion is really difficult to make, and especially this kind of shape, or also shape that they are more natural. And we want to achieve the goal to have at least material as possible with a smart design. With this one, that with extrusion technique is not really doable. Oh, sorry.
Okay, another question from Morgan is, I'm curious how the binding works. Is it an aqueous brine solution react with powders like conventional cement, or are you binding the powders with a cement mix?
No, I'm binding. So the mix is just cement and sand. So you can use any sand and any cement you want, and the binder is just water, and it can even be potentially salt water.
Great. Are there any other questions? Okay, thanks, Nadia. This was, I mean, I can speak for a lot of the chat people in the chat as well. I think this was really fascinating. I'd love to see this work, and I can't wait to see what you do next. Hopefully you can come back next year and give us an update on where you're at.
Yeah, really hope right now we're really busy with the coral texture project, and we are trying to create collaboration on your side of the ocean, Colombia and Hawaii, to test our technology with real coral. So testing different way of connecting the corals with our structure and to implement them in the water. We're really also trying to make our structure multi-purpose, so not only artificial reef and just breakwater, but combine both of them functionality and put it there together. And there is no product at the moment that can do both, so can keep care of the marine life and the coastal protection. Like, for example, we have this tetrapod of the big cubes that they are not really friendly for the marine life. It doesn't really improve the marine life.
So when do you expect to have the first results of your tests back?
In 1 year time.
1 year. Perfect. Well, we'll see you here hopefully in a year.
Perfect.
Great. Well, thanks, Nadia.
Thanks. Bye-bye.